In this video, we're going to be discussing regular polygons. So in a previous video, we discussed what a polygon was. It's just any shape that has three or more sides. So a regular polygon is a polygon where all of the sides and all of the angles are congruent. Okay, so that means that if I've got a triangle, I know that all three sides are the same length and all three angles are the same. In a triangle, we call them equilateral. But an equilateral triangle is just a regular triangle. Okay? If I've got a quadrilateral and it's regular, we call it a square. And the rest of them, if they're regular, we just put the word regular with them. A regular pentagon, a regular hexagon, a regular heptagon, and so on and so forth. All right? So regular just means all the sides are the same length and all the angles are equal. Okay? So in a regular polygon, I can find the measure of each individual interior and exterior angle using the number of sides. Okay? And this is only possible if the polygon is regular. Okay? We can't figure out individual angle measures from the sides unless we know that they're regular. Okay? So it's fairly simple. In a previous video, we talked about the sums of the angles. And we knew the sums of the interior angles, or the sum of the interior angles of any polygon, was 180 times n minus 2, where n is the number of sides. Okay? Well, in a regular polygon, since I know all the sides are the same length and all the angles are equal, if I figure out that angle sum and divide it by the number of angles, then I figure out exactly how many are exactly the measure of each angle. So it's simply angle sum, 180 times n minus 2, divided by the number of angles. Okay, remember, number of sides, number of angles is the same thing. Similarly, I know the sum of any polygon exterior angles is 360. So if it's a regular polygon, to find the exterior angle, I simply divide that 360 by the number of angles, which is n. Okay, so it's really easy. It's just the angle sum for interior and exterior divided by the number of sides or number of angles, however you want to look at it. So let's look at some examples. Example 1 says, find the measure of each interior and exterior angle of a regular 14-gon. Okay, so this is fairly simple. I know my n equals 14. So all I need to do is plug that into each one of my formulas. So for my interior angle, it's 180 times 14 minus 2, that's the angle sum, divided by 14, the number of angles. All right, that's 180 times 12 over 14. I don't know why this is here twice. Okay, that's 2,160 is 180 times 12. And then divide by 14 to get roughly 154.29 degrees. Okay, and when we're doing problems like this, it's probably good to round to 2 decimal places. The exterior, it's even simpler. We simply do 360 divided by n, which is 14, which is roughly 25.71 degrees. You can see that these two add to 180. So another way you could do this is you could simply find one of them and subtract the answer from 180 to get the other. Like we could have just done 360 divided by 14, that's 25.71, and then done 180 minus 25.71, and we get 154.29. Okay, either way works. This is just using the formulas. Example 2 says, a regular polygon has an interior angle measure of 140 degrees. How many sides does the polygon have? So this is going the other way, and there are 2 ways to do this problem, and I'm going to show you both. First way, I know that 140 equals 180 times n minus 2 over n using our formula. Okay, and I'm just going to solve this equation. Okay, multiply by n on both sides, I get 140n. On this side I just distributed, so I get 180n minus 360. Add 360 and subtract 140n on both sides, you get 360 equals 40n. Divide by 40 and you get the n is 9. Now the other way of doing this is I know that if I take 180 minus 140, I get 40 degrees. That's the measure of each exterior angle of my polygon. Well then, I know that 40 is equal to 360 over n, because that's the sum of all the exterior angles divided by the number of angles. All right, well, then I just multiply both sides by 40n. You see I get the same thing here. Divide by 40, and once again I get n equals 9. So you can do this either way. Okay, you can use the formula for interior, or you can subtract the interior from 180 and use the formula for exterior. Either way works. You see you get either way that the number of sides is 9. And that is how you can use relationships between angles and sides in a regular polygon to find some missing values.